So we know Hamilton's variational principle, right? We know Hamilton's variational principle. So, okay. So let's now go to first topic sa finals. The Lagrange equation. This will be the first topic sa finals. Lagrange equation. Equation of motion. Mo man yung pinaka-goal, no? Ang pinaka-goal sa theoretical mechanics, sa Lagrange mechanics is to calculate or to determine the equation of motion. And dungagan ako, I will consider only systems that are conservative. Okay? So, for conservative systems. Okay? For conservative systems. Okay, so let's derive um, the so-called Lagrange equation of motion for the conservative systems. So we will derive this one from Hamilton's variational principle. Okay? So, ma-derive na to ni by the way, I will just write the this Lagrange equation of motion which kinahanglan nyo siya i-familiarize or mas nindot kung i-memorize nyo or what. Muna ang heart sa Lagrange mechanics. The Lagrange equation of motion is given by this Q i's minus, so please familiarize this equation. L Q i's equal to 0. I think kung mag-diagnose, kung mo proceed mo og masteral say sa UP for example, pinaka-basic is we have this equation of motion, we have sa math we have eigenvalue problems, matrices, sa quantum mechanics eigenvalue problems, napod sa math and the normalization of wave function and so on. So, kana nasakol ninyo sa kung apply mo masteral or what. Nasa sa exam. Okay, so this is the Lagrange equation of motion. So please take note of this. This is the Lagrange equation of motion where L is the Lagrangian. We know this one. L is the Lagrangian. It is just equal to, once you know the Lagrangian, so dako na sa points, no? Once you know the Lagrangian of the system, you can actually get the equation of motion by or using this Lagrange equation of motion. So the L, partial L with respect to QI's, so what are these QI's? QI's are the generalized coordinates. So ikaw, depende sa imong system, generalized coordinates. So depende sa imong system, kung unsa ni imong QI's, XYZ ba ni siya, R theta phi ba ni siya, dako ba ni nga X, dako ba ni nga Y, so ikaw bahala unsa imong gusto nga generalized coordinate, unsa ang suitable nga generalized coordinates ang naa sa imong system. Okay, so QI's are generalized coordinates, QI dot are the velocities. Okay, take note. Kung i-derive nimo ang position, you will get velocities, or yeah, you will get the velocity of the particle. Okay, so we have T is time, of course. L is Lagrangian, QI's are generalized coordinates, and QI dot are generalized velocities. Okay, are generalized velocities. Question is, where did this equation come from? No? Yes. Isa to. Euler Lagrange. Yeah, you're correct. Ito? Pilirin, yeah. We also call this one as Euler Lagrange equation. That's correct. Okay. Okay. So Lagrange equation of motion, Euler Lagrange, and so on. Okay. So they are the same, no? They are the same. So question is, asa gikan nganong why is it that nakoy nga ning equation? So asa gikan where asa siya giderive? Okay. Basic giderive siya from the Hamiltons. So it is derived from this, which is na-discuss na ako ni last time, no? The Hamilton's variational principle. So I can derive variational principle. So, ma-derive na ko itong Euler-Lagrange or Lagrange equation of motion using this Hamilton's variational principle. And we know this one. It's all about J equal to integral L dt, no? So, ma-derive na ko siya gikan ani, no? Sa J, which is integral of L dt. Okay, so let's start, no? So, to derive the Euler-Lagrange or the Lagrange equation of motion, let's start from the equation of our, from this Hamilton's variational principle, and it states that J is just the integral of the Lagrangian dt. Now, if you take the variation of this, kung kaano mo, say, more derivative, no? Variation of this is equal to 0, integrated from initial time to final time till 2. So we assume that the Lagrange is a known function. The Lagrangian L is a known function of the generalized coordinates Qi's and Qi dot. Okay, so we express L as a function of Qi's and Qi dot. Okay, so we assume kay depende lang na sa system, no? Kung si L mo kay in terms ba siya ni XYZ, in terms ba siya ni R theta phi, and so on. So, let's generalize it to generalized coordinate Qi. So, we assume that the Lagrangian is a known function. Is a known function. So, ang pinaka-crucial lang man nga part is ang same sa inyong exam. Ang pinaka-crucial nga part is ang pag-determine sa Lagrangian sa usa ka system. Okay? Kung complicated nga system, then maglisod ka og determine sa unsa yang expression sa Lagrangian. So it's a known function of the generalized coordinates, generalized oops general sorry of the generalized coordinates katong katong mga QIs nato, position and the velocities Qi dots. Okay? Qi dots. So L is a function of Qi dot, and of course time, no? It's because Qi and Qi dot is a function of time. So, yeah, L is a function of Qi's and Qi dot. So, as you can see here, the change in J, the delta J, which is equal to delta L dt, which is equal to 0. If you derive the L, this is actually a partial derivative because your L is a function of Qi and Qi dot. So, daghan siya nga variable sulod sa imong L. So, if you take the variation, you will take the partial derivative of your L. Okay? So, you will take the partial derivative of our L. Ang ano ganito kay si L is a function of two or more variables. Okay? So, in this case, we can have delta L. Okay, si delta L, again, delta L, since L is a function of Qi dot, delta L is just equal to partial with respect to Qi's plus partial with respect to Qi dots. Okay? So, si delta L is just equal to this, partial of L, Qi dot, change in Qi, right? This is a partial derivative, no? Using chain rule, pwede ka mag-upload, yeah, I will use chain rule, plus partial L with respect to Qi dot, change of Qi dot. Okay. And take note here, these are generalized coordinates. So, depende kung sa pila ka buok Qi's ang nasa imuhang system. So, in this case, we will sum all of these generalized coordinates. So, therefore, we have the so-called summation here of i's, depende kung pila ka buok generalized coordinates ang nasa imong system. So, delta L here is just equal to this summation of i's. So, usually kung in 3 dimensions, i's are 1, 2, 3, or x, y, z, and so on. So, summations of i's, partial derivative of L with respect, duha man ka buok ka function ako ang L, no? So, i-derive na ko partially with respect to Qi's, plus, i-derive na ko siya with respect to Qi dots. Okay, Qi dots. So, mura sa gani, no? Katong, kung kabantay mo, like, ako x square, y square, derivative, you will, not this one. You have partial with respect to x, x square y plus partial with respect to y, x square y, and so on. This one is dx, okay? This one is dx and dy, okay? The delta qi's are dx and dy's. Anyways, so that we can expand the delta L in terms of that. So, na ako'y duha ka terms, okay? So, na ako'y duha ka terms sa ako ang delta L. So, therefore, the J, ako ang J is just equal, the delta J, sorry, the delta J is equal to this. So, therefore, my delta J, the change in J, is equal to the integral. Ako lang na i-substitute, no? Summation of i's, okay? Partial L, partial Qi's, delta Qi's, plus partial L, partial Qi's dot, delta Qi dot, delta Qi dot, dt integrated from, nakoy integrated from t1 to initial time t1 to initial time t2, which is we equate is this one into 0. Okay. The QIs are functions of time. They change as the system evolves. Okay. So QIs kaning coordinates, generalized coordinate Q are functions of time. Okay. So from time to time mag-change ang imong position vector, mag-change imong velocity and so on. So therefore, the variation of delta Qi's is equal to the difference between two slightly differing functions of any time t. So by this statement, we can say that the delta Qi's that we can actually um, re-express the delta Qi dot as this. You have Qi dot is just this, right? Okay, ddt of Qi's, right? Tama ba? Qi dot is just the rate or the time rate of Qi. Okay, so we can write that as that. And then since ang derivative kay sa tawag ni associative tawag na commute associative tawag na pwede mo sa ma-interchange, no? So we have ddt of the delta Qis. Okay? So I can rewrite this kini into this one. Okay? So pwede na ko siya masulat into that. Okay? So del ddt delta Qi. So therefore, so ako lang isulat otro but i-rewrite na ko ang kaning delta Qi dot sa second term into this form kay nasa rectangle. So therefore, ma-rewrite na ko si J into this integral T1, T2 summation of i's partial L, Qi's, delta Qi's plus, so itong isa partial L, Qi dot. Take note, ako Qi dot. Pero, gi-change na ko ang katong delta Qi dot into ddt of the delta Qi dot dt, and this is equal to 0. Okay? So, ingani siya form. So, what will happen is this. The second term, there's no problem with the first term. Okay? So, ako lang siya as is lang ang ako ang first term. I will change the second term. Okay? I will change or I will express into another expression ang ako ang second term. The second term becomes this. The second term becomes, muna yung second term na ako, no? So, ako ang delta J. Kopyahan lang ako, no? Nakoy partial L, partial Qi dot, tapos ddt of delta Qi dt, which is, this is my second term, okay? T1, then T2. This is actually, you can express this into two terms. We have, the first term is this, summation of i's, partial L, partial Qi's. I think nani siya kaparehas atong gi-derive na to last time. Katabi taong gi-change na natay function of eta. Kung kadumdum ato, no? So, somewhat na ingani siya form. Qi's from t1 to t2 minus integral of this d dt of partial L partial Qi dot delta Qi dt. Okay? So, asa na po ligikan na po? You will use integration by parts. Okay? If I use integration by parts, of this one, using integration by parts, and this will be your assignment. Okay? So, I will not integrate this one. Your assignment will be using akong hint is using integration by parts. Show that the second term is given by this form here. Okay. So ako na i-post na lang daan kay bas makalimot na po ko, no? So this will be your assignment. But assignment sa first assignment sa final term. So ako na oops. Sorry. Oops. Paint. Post na lang ako na daan, no? Again, you will use integration by parts to solve the second term or to show that the second term is equal to this one. Okay. Assignment. Post na ko daan kay basi makalimot na po ko. Okay, again, the second term, using integration by parts, it is equal to these two terms. Okay, it is equal to these two terms. But the first term becomes 0. Okay, the first term becomes 0. Why? Because of this concept that at the end points, because of this concept na at the end points, there will be no change or there will be no variation. So if you integrate this, as you can see, this first term becomes 0. Why? Because if you integrate the delta Qi's from substitute ang T2 minus T1 here in your Qi's are functions of time, and ang makuha nimo actually is na ako delta Qi T2 tapos Qi T1, and I know that at endpoints sa T1 first point, initial point, and final point, there will be no variation. Wala ako'y change in QIT2 and QIT1. So, therefore, this is equal to 0. Okay? So, naman tayo gi-assume last time, no? Itong gi-assume na ito nga last time nga at the endpoints, there will be no variation. Okay? At the endpoints, there will be no variation. Sorry, ito na ito. This one, ha? Oops. Where is it? Okay. Yeah, at the endpoints where the variation is constrained to be 0. So, we note that one. At the endpoints, the variation is constrained to be 0. No variation at endpoints. No variation at endpoints. Okay? So, the second term, mahi mo siyang equal lang siya aning negative integral of this dt and so on. So, kani siya na term is just equal to this one. Okay? Is just equal to that one. Okay? So, equal lang na sa dira. So, I can re-express again the second term of our delta J, which is equal to this. So, i-re-express na ko siya into that. So, it becomes this. Na po, delta J, which is equal to 0, is just equal to summation T1, T2, summation of i's, partial L, partial QI's, na po QI's, minus, no? Minus na to, no? D dt of partial L, partial QI's, delta QI's dt, which is equal to 0. Okay, aha, tama ba? Na po d dt, partial L of QI dot delta QI is dt, which is equal to 0. And as you can see here, if you factor out the delta QI, so you will get this. Ako delta J, ako summation of i's. Makita na ninyo ang Lagrange equation, no? Ako kani minus d dt of partial L, partial QI dot. Okay? Pagawas na ko ang QI, dt, and it is equal to 0. And notice, this is an integral, okay? So, kanus ang 0 ang kaninga integral if the integrand is equal to 0. This can never be 0. Mag-0 siya kung nasa sa endpoints, no? Mag-0 ni siya kung nasa endpoints. Dt is just dt. So, kanus ang ma-0 ang integral when this one is equal to 0. Okay? Thus, as you can see, from using variational principle, using Hamilton's variational principle, we successfully derived the Euler-Lagrange equation, delta L QI's, and this is equal to, QI dot ni siya, no? QI dot. This is equal to 0. And we call this one as the Lagrange equation of motion. So, dahil lang, no? So, kung pangutanon ka, yun sa pag-derive ang Lagrange equation of motion, very simple. You will just use Hamilton's variational principle. The delta J, which is integral of L dt equal to 0. Dito gikan ang kaning Lagrange equation of motion. Sometimes, dunay book nga ang ilang gamit is gi-equate nila ang negative. Sometimes we can put that one as this. QI is equal to d dt of partial L with respect to QI dot. Okay? So sometimes pwede na ako isulat ang Euler-Lagrange equation of motion na ako into that one. Pero pwede na po minus, no? Pwede na po kung minus. Same na siya, no? Igo lang mo siya i-transpose, you will get the Lagrange equation of motion. Aha! Okay, so diri na dayo, no? Nana ko Lagrange equation of motion. Nana ko Lagrangian. I can solve the equation of motion of any given system. Mapa-complicated pa na siya or dili, o mapa-complicated or mapasayon. Makuha na ko ang equation of motion. As long as you have this L, this Lagrangian L. Okay. Say, for example, pinaka-simple is ang free fall, no? Free fall. Sa free fall, I know that m acceleration force is equal to minus mg, right? Or you can write this as mx double dot equal to minus m times g. So this is the equation of motion for free fall. Now, using Lagrange equation, okay, using the Lagrange equation of motion, I can actually calculate this. So, ma-derive po na ako ng expression for free fall. Because I know for free fall, the Lagrangian is just equal to 1/2 mx dot square. There is no potential, right? Okay, free man siya, no? There's no potential. Zero potential siya. So, the Lagrangian for free fall is equal to this one. It's just the kinetic energy, 1/2 mx dot square. Or if you use y, so it's okay, no? Kung vertical position, you can use y, but In this case, I will just use x. Any generalized coordinate man lang po akong gamiton, no? Any generalized coordinate man po akong gamiton. So the qi here is x, while the qi dot is x dot. Okay? X dot. Sakto? If you use y, then it's okay. Okay? But the Lagrangian for free fall is just this 1/2 m x dot square. Now, I have the L using this. So, ito. So, kinahanglan memorize na nato ni, no? Qi is minus d dt partial L Qi dot equal to 0. Okay? The Qi here is x. So, you can write this as partial L with respect to x minus d dt partial L with respect to x dot. Okay? And then, diri rin na ito masulod ang ato ang talent on derivation. Okay? Ang talent na to on derivation. So, once we know how to derive, then there's no problem with it. Okay? So, if my L is equal to mx dot, so the delta L with respect to L, partial L with respect to x, this is partial x with partial with respect to x na ako'y 1/2 akong L, no? Since L for free fall is 1/2 mx dot square. So, I have 1/2 mx dot square. Pila ni? Pila ni siya? If I derive partially the 1/2 mx dot square with respect to x, pila ako answer?
0, sir.
0. Yeah. Because, take note, 1/2 mx dot square is not a function of x. So, the partial derivative is himo niya ning constant. Derivative of constant is 0. Okay. How about partial L with respect to x dot? So, partial L with respect to x dot of 1/2 m x dot square. Pila mo ni siya?
mx double dot, sir.
Mx double dot? Or mx dot lang sa?
X dot.
Mx dot pa, no? Mx dot pa siya, no? So, mx dot. But, the d dt of this, x na ang gamit, no? Dili na q. Ako na siyang na simplify into x dot. So, this is d dt of mx dot, which is just x equal to mx double dot. Okay? Ay, kulang ko. Sorry. Free, not free fall, but free particle. Sorry. This is free particle. Sorry. Free particle. Free particle. Okay. Later ng free fall, no? Later na ng free fall. Okay. Free particle lang sa, no? Free particle. So, next is I will get the equation of motion for free fall. This is for free particle. Kung may free particle, take note, there's no potential. V is equal to 0. Okay? Free particle means V is equal to 0. So, we have that, mx double dot. So, therefore, for free particle, not free fall, not free fall, but free particle. For free particle, libo ko sa free particle of free fall. Di sa parehas, no? Free fall kaya nasa potential energy because free fall is na kay gravitational field, gravitational force. So there will be a potential energy. Okay? So for free particle, we have partial L with respect to x minus d dt of partial L with respect to x dot. This is equal to 0 minus mx double dot, and this is equal to 0. So therefore, for free particle, of course, mx double dot is equal to 0. So no force, first law of motion, the law of inertia, F is equal to 0. Now, free fall ta, no? So for free fall, again, I have this. This is the ground. I will use x. Okay, I will use x, not y. So this is x above the ground. So the L is equal to same gihapon ang kinetic energy 1/2 mx square, and there is there will be potential energy which is equal to mg times x. Sakto? Uh, Positive. Take note, L is equal to T minus V, no? So, your potential here, since your M is above the ground, this is the ground, okay? I'm considering that above the ground is positive. So, there will be a positive potential energy, which is just equal to mg times x. And let's see whether we can have this mx double that for free fall. Take note, that is equal to minus m times d. So nataldo kung kani ato makuha gyapon nga equation using the Euler-Lagrange equation. So duha lang man kabuok ang kuha, no? First is the partial L with respect to x minus d dt of the partial L with respect to x dot equal to 0. Since I only have 1 degree of freedom, so therefore nalang po ko'y isa ka Euler-Lagrange equation. Okay, take note of that. Kung na ako'y duha ka degrees of freedom, say x and y, then I have two Lagrange equation of motion in terms of x and in terms of y. Doon na po'y itawag siya nga coupling, no? So na mag-couple sa ilang duha. Anyways, but if I have pila ka buk degrees of freedom, ingana pod kadaghan ang imuhang makuha nga Euler-Lagrange equation of motion. So with respect to x, with respect to y, tagsa-tagsaon nimo, no? Tagsa-tagsaon nimo kada coordinates. So in terms of r, in terms of theta, in terms of and so on. In free fall, 1 degree of freedom lang. So therefore, isa lang kabuk Lagrange equation of motion, which is just in terms of x lang. So this is my Lagrange equation of motion, and if I do derivatives, you will get partial L with respect to x is just equal to partial of this function 1/2 mx dot square minus mgx. This is just equal to minus m times g, no? Minus m times g, while partial L with respect to x dot, this is just equal to mx dot. Same raman, no? Mgx is constant with respect to x dot. So, nakoy nga na. So, therefore, d dt of partial L, partial x dot is just equal to mx double dot. So, if you combine the two, using the Euler-Lagrange equation, you will get minus mg ba? Yeah, minus mg minus mx double dot equal to 0. So, therefore, for free fall, na ako'y equal to this one. Okay? So, the equation of motion for free fall is equal to this function here. Okay? So, nga lang sa'yo, no? Iguro ta mag-derive, no? There's no need for you to draw forces in the system, no? Kaya usahay ka maglibog ta, asa padulong ang tension force, asa padulong ang mga friction force, and so on, no? But using Lagrangian mechanics, you just have to get the Lagrangian of that function and then derive it using this. You will get the equation of motion. Lastly, last na lang, no? For harmonic oscillator, okay, for harmonic oscillator, I think nahatag na nako ang Lagrangian ni harmonic oscillator, no? Nakoy nga ni M. Okay. So, the Lagrangian for harmonic oscillator is we have 1/2 mx dot square minus 1/2 kx square, no? Kinetic energy is 1/2 mx square dot, while the potential energy is just the elastic potential energy with some spring constant k, no? 1/2 elastic potential energy is 1/2 kx square. So, if I have that, if I derive this with respect to x, what I will get is we have minus kx, sakto? Minus kx, and if I derive this with respect to x dot, I will get mx dot, and then the d dt of this is we have mx double dot. So therefore, the Lagrange equation is given by this x dot minus d dt partial L x dot, okay, equal to 0. This is kx minus kx ba to? Minus kx minus mx double dot equal to 0. Therefore, mx double dot is equal to negative k times x. Okay? So, nga na lang, no? So, this is for harmonic oscillator, no? Tama ba? plus kx equal to 0, or you can write this as x double dot plus k over mx equal to 0. Then you can write this as omega square. So therefore na po x double dot plus omega square x equal to 0, where omega square is equal to k over x. So this is for using sayon lang, no? 3 pila lang kalinya, tulo lang kalinya, masolve mo ang equation of motion for harmonic oscillator. Okay? For harmonic oscillator. Okay? So that's it for today, no? That's it for today. So pinaka basic is we have this equation for our Lagrange equation of motion, or the Euler-Lagrange. Once I have the L, then do derivatives, you will get the equation of motion. Okay. Any question? Sayun ra, no? So next time, we will answer more complicated problems like simple Atwood machine, duha ka buok, and then let's do double Atwood machine. Katong tulo ka mas 1, mas 2, mas 3. Mas 1, mas 2, mas 3. Tanaw na to ang equation of motion na. And also katong sa inyong midterm exam, katong pendulum o mass, dahil na pendulum na nagbitay, we will get the equation of motion for that later. Okay? So I will give lots of examples or lots of problems, complicated problems or simple problems, basic physical problems nga naa sa libro. We will do that. We will solve that, the equation of motion for that, using the Lagrange equation of motion. Okay? Question?